Assalamualaikum warahmatullahi wabarakatuh to Madam Rohana binti Jaafar. So today, our group will present about the Jacobi method. First of all, let me introduce my group members. My name is Nur Iza Akila binti Amram. The second one is Nur Kairunisa binti Muhammad Khairi, and the last one is Nurul Aisyah binti Cik Asnu. Here's the table of contents. For the first one, introduction. The second one, problem statement. The third one is problem solution. And the last one is the conclusion. So next, let me proceed to the introduction. For the Jacobian method or Jacobi method is one of the iterative methods of approximating the solution of a system of n linear equations in n variables. The Jacobi iterative method is also considered as an iterative algorithm, which is used for determining the solution for the system of linear equations in numerical, which is linear algebra, which is diagonally dominant. In this method, an approximate value is filled in for each diagonal element until it converges. The process is iterated. The Jacobian method is also known as the simultaneous displacement method.
Assalamualaikum and hi, my name is Nur Khairunisa binti Muhammad Khairi. I will explain the problem statement and also the solution. For the problem statement, consider the following system of linear equation: 6x1 plus 2x2 plus 5x3 equals to 13. And the second equation is 2x1 plus 4x2 plus 7x3 equals to negative 1. And the last equation is 2x1 plus 2x2 plus 2x3 equals to 7. If the initial approximation x0 equals to 1, negative 1, 0, 3, find x first iteration and x second iteration using the Jacobi method. From the problem set 1, we can get the equation and the value for x0 iteration, which for the x1, x2, and x3 value. Okay, first of all, we need to find the x1, x2, and x3 first, just like how it's shown here. For the first equation, which is 6x1 plus 2x2 plus 5x3 equals to 13, we can use it to find the x1 value when you want to calculate at the first iteration and second iteration and so on. So, because we need to find only x1, we just bring all the left hand side into the right hand side, and it will be resulting, which is 1 over 6 bracket 13 minus 2x2 minus 5x3. And we did the same with the x2 value and an x3 value. This one we not calculate yet for the first iteration and the second iteration. Therefore, when you want to calculate each value that was in each equation, which is x2 and x3, the value that will be inserted here is using at the x0 iteration, just like this. For the x1, x2, and x3, at the x0 iteration is 1, negative 2, negative 1 and 0. Therefore, when you want to find the first iteration, just like here, when I use x1 and the bracket x1 as the power at here, means that it is want to find the first iteration. So the x1 for the first iteration, just like I said before, the value of x2 and x3, just use the x0 iteration. Therefore, just insert each of the respective value, which is -1 and 0. It will be resulting x1 at the first iteration is 2.5. We do the same for the x2 in the first iteration and also x3 in the first iteration. So it will be resulting both of the value is -0.5 and 3.5. So when you want to find the second iteration, we cannot use the value x0 iteration because we already use it and when to find the x1, x2 and x3 in the first iteration. When you have to update the value, which is the first iteration value, and when you want to find the x2, we need to use the x1, x2 and x3 in the first iteration. Therefore, to calculate x2 to calculate at the second iteration, we'll be using the 2.5, -0.75 and 3.5. For this value, when you want to find the x1 at the second iteration, we just insert it, the value that we already got in the first iteration. So the x1, which is 1/6, equal bracket 13 minus 2x2 minus 5x3. So the value for x2 will be using -0.75, while x3 will be using 3.5, just like here, what we shown here. So we just insert the respective value from what we got in the first iteration. Therefore, for the x1 in the second iteration will be -0.5. We did the same with the x2 in the second iteration and x3 in the second iteration. Therefore, the answer for the x2 and x3 will be -7.625 and 1.75. From this, what we can conclude that is whenever you want to find a new iteration, just use the letters that be given to you, just like x1, x2 and x3 in the first iteration. We use the value of the x1, x2 and x3 at the x0 iteration, while when you want to find the second iteration, x1, x2 and x3 will be using the first iteration value for the x1, x2 and x3. Therefore, that's what I can say and conclude for the solution.
My name is Nurul Aisyah binti Asnu. For the conclusion, we will tell you about advantages of Jacobi method. First, it is simple and numerically robust. Second, each iteration quite fast. Third, it is highly desirable for many applications. And lastly, the Jacobi method first generates an exact result and subsequently refine its result at each iteration, with the residuals converging at an exponential rate.